100.1.1.3. And in a static way. But the configuration of light input is not enough. Cisco is more troublesome. In Cisco, you have to specify the internal network interface and external network interface. Now the data flow is like this. PC1 sends data. Come in from this interface of the gateway. Then go out from this interface of the gateway. Then this interface will be an external network interface for you to do NAT. This interface will be an internal network interface for you to do NAT. So you need to be under these two interfaces respectively. Indicates that they are the interfaces used in NAT. So we now first enter this E00 interface. IP NAT outside. This is my external network interface for NAT. After we enter this command, it will be stuck for a while. Wait a minute. Anyway, this command will get stuck every time it is entered here. So don't think it's a problem with your own equipment. Now 00 is outside. 01 is inside. That is, when you do address translation, which is the internal network interface? And which is the external network interface? That's what I mean. Okay. Then enter the 01 interface. IP NAT inside. And we're back now. To view the mapping table. Show IP NAT translation. Now this is called NAT mapping table. In the table it says inside local. That is an internal private network address. This is 192.168.1.10. Maps to this external 100.1.1.3 here. Then we describe the process. PC1 wants to go online now. It accesses 8.8.8.8. Cross network segment. Find gateways across network segments. The data is sent to the gateway here. Since this interface is the internal network interface of NAT. After checking this data, if you go to 8 now, need to go out from this external network interface again. So at this point it will start NAT. Because it also happens to be 1.10 now. After the data comes in, the gateway knows that it was sent by PC1. PC1 wants to go online. Then this static NAT will take effect. So the start of NAT needs three conditions. First, must come in from the internal network interface. Second, must go out from the external network interface. Third, there must be this corresponding representation in the NAT table. Data to go out. Then once the data is now out, can you guess PC1 can ping 8.8 now? Let's verify. 8.8.8.8. When pinging, we get a packet here. I'll put a mark here first. Wait a minute to see what message is sent if it is connected. Look. Here's a dot and 4 exclamation points. This proves it works. After we pass, we will suspend. Let's take a look at this message. It didn't work. Originally, this packet was sent from 192.168.1.10 to 8.8. Now this is sent from 100.1.1.3 to 8.8. So you see that 8 replied to 100.1.1.3 with a packet. Because 8.8 is a device of the operator. It has a route about 100.1.1.3 on the device. That is the 1.0 network segment. Because it is directly connected. So it has such a route. With routing it can reply packets. Original no reply packet. It is because it does not have the route of the private network IP. So no reply packet. Then you will find. Now the source address has been modified. Changed to public address. Let's do a simple demo. I'll talk about other things later. I won't get data packets for everyone. Time is tight. If you are interested, you can try it yourself after class. Now the entire Ethernet communication must use ARP. It's a stipulation of the agreement itself. Okay. We just finished talking about static NAT. Let's talk about something else. We are now online normally. After going online normally, we can look at a parameter on the host just now. Show IP NAT. Let's take a look at the mapping table just now. This is a static mapping. Mapping from an internal address to an external address. In fact, static NAT is a two-way mapping. That is, whether from the inside out or the outside in, it is all mappable. So, as a static NAT, even if internal hosts do not access the internet, once it is bound to the address of the external network, then this public network address cannot be used by others. So it's very unoptimized. So can we optimize static NAT now? For example, now when I am doing data access, if I want to use this address, I will take it and use it. If you do not use this address, I'll return it for someone else to use. It's okay too. We have a method called dynamic NAT. But whether static or dynamic, we don't use this much. So let's take a brief look at its configuration. Don't need to do too much research on it. We don't use it in real life. Because as a dynamic NAT, it will also have a release time. That is, it still defines the pool here. When we talked about DHCP before, actually defined this thing. Address pool. The public network also needs to define a public network address pool. You will find that there are still two public network addresses inside. Of course, there may be more in the future. Then it means host A finds an address when surfing the internet. Host B finds an address when surfing the internet. If the future is not online, return this address to the address pool. For example, in the future, host C wants to communicate. It can take the address and use it. It is compared to static NAT. The advantage is, when I use it, it is actually a private network occupying a public network. It's just that the difference is, if I don't use it, I will return this address for someone else to use. But this method still requires a lot of public network addresses. Otherwise, when the intranet host is online, they are still all facing one traffic at the same time. Concurrent traffic. If it's still like every day, host A goes online. Host B goes online after a few minutes. In this case, one address is enough. But in real life it is often impossible. I want to go online. We have to wait for the previous person to release the address first. Then I go online. This doesn't happen in our daily life. Even in such a way, it can recycle addresses and reuse them. But for the high concurrency traffic in the current network, it is far from meeting our current configuration requirements. We won't use it in practice. So let's configure it. We mainly look at its configuration direction. No matter what kind of NAT, both the network ingress port and the network egress port need to be configured. The ingress and egress ports are the two interfaces 00 interface and 01 interface. We should have configured. Actually, we call dynamic NAT many-to-one or many-to-many. Multiple internal private network addresses to multiple external public network addresses. We dynamically make an allocation. And for NAT, it needs to be used in conjunction with ACL. ACL and NAT can be used in combination. Like static NAT. You don't need to use it in combination. By default, if this ACL does not define, then it is assumed that we have not obtained any data. NAT will only convert the matching data for ACL. That is, What data is obtained by ACL? What data is converted by NAT? If you don't write any rules, the default is not to do NAT translation for any address. It must be converted when it is combined. If it doesn't match now, don't convert. So I can't get online. So wait a minute while we configure. We also need to configure the ACL. This is one of its configuration specifications. For ACL, use ACL alone. Just one of the methods. When we were configuring the ACL just now, you should see the route map there. ACL can be used in combination with many other directions. Actually, it can be used alone, and there are also scenes.